Okay, so welcome to this joint meeting of the SWOT Data Inversion and Assimilation Working Group and the High Resolution Modeling Working Group. So this is a joint meeting of convenience because we wanted to avoid Easter Monday last week, but the topic is highly relevant to everybody. And so today we have Maxime Bellarotta, who's going to talk about the MIOST L4 product with SWOT version 3.0. So he'll talk for a bit, we'll have questions, and then of course, because it's a working group, we should have time for discussion about any topic that is of interest or concern for people online. So take it away, Maxime.
Thank you. So thank you for the invitation. And yeah, as you say, I will present the latest version of the level 4 product that has been produced with MIOST and available on the Aviso website. So to introduce a little bit, so everybody have seen more or less this figure already, where on the left we have a kind of 2D image from SWOT with resolving approximately 15 wavelengths. And on the right, we have the DUAX product that are available on the Copernicus Marine Service, that are a combination of all the available nadir altimeter observation and filling gap with a mapping method. And this product has more or less 150 kilometer effective resolution. And so since SWOT is flying, so there is two main motivation from in the level 4 community is how this carrying observation can be optimally integrated in the gridded product, and also also to quantify the reduced mapping error thanks to this new observing system. So at CLS, so we are mainly working on the tool that has been developed by Clément Hubelmann, so the MIOST system, which take as input altimeter observation, and physical components are declared as a wavelet basis, and the variational core minimize the system to finally produce map of mesoscale map. But the MIOST system has also been applied to solve other problems such as coherent internal tide mapping, or at the beginning it was developed in the context of the scheme, as far as I remember, scheme observing system. And also one important part that I will talk a little bit at the end of the presentation is that also within this framework, we can also estimate some other modes that are specifically instrumentally oriented, such as estimation of long wavelength error, orbit error, some residual errors that could persist on the constellation, so altimeter and SWOT, and that is used to harmonize, homogenize the level 3 constellation. So for the level 4 product that has been produced recently, so we use as input the level 3 dataset, so the V3 from SWOT at 2 kilometer resolution. And also we combine it with a long track level 3 dataset that are available in the Copernicus Marine. So the time frame covers the SWOT period till the end of 2025. And for the nadir altimetry product, we both combine delay time product. So that's the, I don't see, do you see my pointer on the screen? So the second line, the delay time product, and the near real-time product, since the delay time product were not available after mid-2025. So in terms of constellation, is mainly between 7 and 8 nadir altimeter that are observing the ocean surface topography. So it's relatively dense in terms of nadir altimetry, and we combine with even denser observation at 2 kilometers from the SWOT system. In terms of output, so we deliver the level 4 product on NetCDF format on a regular grid at 1/8 degree grid spacing. It's daily grid, and it's daily time processing on the Aviso website. So as I say, the period that is available in daily time on Aviso is up to the end of 2025, and the variables that you will find in the product are sea level anomaly, geostrophic current anomaly, and the absolute dynamic topography and absolute geostrophic current. So we have an illustration on the bottom of the sea level anomaly and the geostrophic current, so with a kind of classical picture of the mesoscale that we know from altimetry at global scale. Since SWOT is flying, so there have been several releases of the level 4 product on the Aviso website, from the V0, 3, V1, V2, and now the V3. So in terms of upgrading of the system, so basically the first version of the level 4 product was based on the MIOST version that was specifically tuned in observing system simulation experiments. So we perform OSSC in simulating SWOT observation and nadir observation, and we tune the system in order that he was ready when the first real SWOT observation arrived. So the first map that we produced were quite nice in terms of performance of this first integration of the real Carine dataset. But we saw that in some region there was, in particularly in the equatorial region and region of internal wave or incoherent internal wave region, there was some degradation of the mapping, and that was some contamination of unbalanced motion or internal wave correction that were not available on the Carine dataset. So incoherent, and they are still not, I think, available. Then for the second release, there was no significant upgrade in the system, but to improve the system, we introduce, so we revisit a little bit the a priori noise level that we apply in the mapping system for the Carine instrument. And we also introduce dedicated mode in the MIOST system to partially absorb this incoherent internal tide signal. And these two approaches led to improvement in this region where unbalanced motion and pollution of or contamination of incoherent internal tide polluted the level 4 product. And for the latest version, there was no major upgrade in the MIOST system. In terms of validation, so the two classical validations that we perform internally is that we produce specific map. So this is illustrated on the left. So we exclude one long track dataset, nadir dataset, and do specific level 4 product, and then validate the specific level 4 product to this independent dataset to quantify the error, the mapping error that is illustrated here on the animation. So the error are here in centimeters, and the independent long track dataset is Sara-Laltica. We can also perform a validation on the geostrophic current in manipulating so in situ dataset, so basically drifters that are distributed in the Copernicus marine systems. So it is both surface and 15-meter depth measurements. And we apply several corrections to really compare geostrophic current from the map and an equivalent of the geostrophic current from the in situ dataset. And at the end, so we perform this kind of analysis where we have some kind of average map of error, so for the long track, and also average map of, so in terms of sea level anomaly on the left, and in terms of geostrophic current on the right. And we also isolate the metric in various regimes, oceanic regimes, such as offshore high variability region, offshore low variability region, coastal region, and the equatorial or polar region. So that's the kind of classical assessment that we perform on this global map. So before showing this quantitative result that we perform, just to have a kind of sensitive, have a feeling of what is the impact of introducing carine in MIOST. So here it's a picture where you have, so on the left, you have the Nadir constellation. We are here, I think, in the ACC, in the Antarctic Circumpolar Current. So you have around the date, so the 19th of December 2024, plus minus 4 days, you have the altimeter constellation, Nadir altimeter constellation in the region. On the right, you have the SWOT observation within plus minus 4 days. And in the middle, so you have two reconstruction, one that is done only with Nadir altimeter here, and then Nadir altimeter plus SWOT. And qualitatively, from these two maps, if we isolate, for example, one band here, we can see that in terms of structure or pattern of the structure here, one structure that was only one, let's say, eddies in the map that are only constrained with only Nadir altimeter is we better follow the structure that is seen from the SWOT observation. So basically here, this closed eddy here is better represented with adding SWOT in the system. And potentially, this kind of better representation or representation more closer to the SWOT 2D observation is translated to better map or reduce mapping error at the end. So basically, the change, the major change that you will see in the product are so this better, so improved representation of the shape and the amplitude of the structure in the level 4 product. So in terms of key validation results, so now I move to the quantitative assessment that I illustrated before. So here the validation is done against an independent long track dataset, so Sara-Laltica. And so on the top here, you have the mapping error of the level 4 product for specific wavelength, so considering all spatial scale or for scale below 200 kilometers, so short spatial scale. So you have the variance of this error with the Nadir altimeter constellation only. And the figure on the bottom is the gain or reduction of error variance when you introduce SWOT. So when it's blue, it means that you reduce the error. So it is expressed here as in percentage. So when it's blue, it means that you reduce the error when you introduce SWOT in the mapping. So what we can see from this picture is that mainly for the short spatial scale, the contribution of SWOT can be large, particularly in the energetic current, for example, in the ACC here, where you can reduce the error up to 15 or 20%. Another diagnostic that has been published as well is the effective resolution that is assessed thanks to the independent long track data set. So on the top, here on the top, so right, you have the effective resolution of the level 4 product, which range between 500 kilometers to about 500 kilometers in the equatorial region to about 100 kilometers at high latitude. So from this diagnostic, we can quantify that SWOT also tend to enhance the effective resolution of the map by about 10%, which correspond to about a scale of 10 to 20 kilometer gain in effective resolution on average in the mapping product, in the level 4 product. In terms of geostrophic current reconstruction, so as I say previously, we can validate against independent drifters data set. And on average, at global scale, we have improvement in introducing SWOT carrying in the level 4 product, and the gain is between 3 to 5% of reduction in reduction of the error on the zonal and meridional component, and the level of reduction of the error is on average quite stable, depending on the region that we select, either globally or high variability, low variability or offshore region. So now I move to the long wavelength error that I have shortly introduced at the beginning. So within the MIOST system, so we have been introducing a 2D long wavelength error mode specifically for Karin. That so this mode has been implemented into account for residual error that could persist in the level 3 Karin dataset. This residual error could provide for imperfection in the correction that are applied on the level 3 dataset, such as the dynamic atmospheric correction, or it could come from as well from the calibration part, orbit error, tides, and etc. And it's kind of signal that have typical scale of larger than 1,000 kilometers along track. So I put an illustration of this kind of the shape of this pattern that we want to estimate on this level 3 dataset. And this approach is kind of similar to the method that has been introduced historically on Nadir dataset, on reference paper, for example, from Pierre-Yves Le Traon in 1998, with already some long wavelength errors that are estimated in the Nadir along track data that are available, for example, in the Copernicus Marine data store. So in terms of structure at global scale of this long wavelength error estimation or correction that we estimate with MIOST. So here you have SWOT track that are aligned vertically over one cycle, and the color represent this long wavelength error estimated for the Karin instrument. So the color bar is between minus and plus 3 centimeters. So what we can see from this picture is that you have strong.
meeting.
Sorry. No, should I continue maybe?
Sorry, yeah, somebody came on and
Okay. So these errors are mainly important at mid-latitude and also in coastal region where you could have some some region where the calibration DAC or tide may still persist in the level 3 dataset. Another way to see it is, so this picture is quite interesting, is if you subtract the level 4 product to the level 3 Carine dataset, you will have a picture of the residual, so between Carine and the map, so the level 4 product. And from this picture, you can see the differences at various scale. So you have large scale bias that are seen and that sign mainly in the level 3 Carine dataset. So that are illustrated, for example, here in the North Pacific, North Atlantic, in coastal region. You have also some small scale patterns that are the submesoscalides that are not resolved by the mapping system. And as well, you could see some internal wave signal that are present in the Carine dataset, but are not resolved within the mapping system or with the correction that are applied at lower level in the processing of the Carine dataset. So it's when we do the correction of the map level 4 product, DUX map, with the Carine dataset. And if you consider long wavelength error on the Carine dataset, you reduce this bias. So that's the picture you can see here by absorbing this residual. So as I said previously, the residuals that we absorb are mainly large-scale residual, but the small scale that are mainly linked to other physical error or ocean signature or not resolved in the level 4 product, they are still persisting in the difference. So qualitatively, we have a better coherency between the level 4 product and the level 3 SSH from Carine corrected from this long wavelength error. Quantitatively, this is illustrated here on upper top panel. So that's the variance of the difference between the level 3 Carine dataset after we apply the long wavelength error on the Carine and the sea level anomaly minus the variance, the variance of the difference without applying this correction. So blue means we have reduced error or better consistency between the level 3 corrected with long wavelength error and the map mainly. So the strong reduction of the appear at mid-latitude and in coastal region. Another diagnostic to look at is also the coherency with other altimetry datasets, such as, for example, Sentinel-3A data. And if we look at crossover, we do see also a better consistency with Sentinel-3E dataset when we apply this correction at large scale on the Carine data. So why I'm talking about that is because so another application that could be useful is so for assimilation part. So here is an example that Florian is performing with his system, Florian Le Guillou, with a Vardin approach, where he saw potentially better benefits of using this long wavelength error correction prior to the assimilation in his system. And maybe Florian will talk about more about it in the next months during his presentation for this working group. So in terms of conclusion, the integration of Karin data in the level 4 product is successful. We have seen that the Karin observation are really benefits in the level 4 processing. So the two-dimensional observation of the SWOT Karin help to improve the representation of the shape of and the amplitude of the structure. Quantitatively, we estimate about between, let's say, 10% on average reduce mapping error. Better consistency with independent data sets and in situ data set when we compare to drifter data. In terms of, so I have put some point about some limitation. So we may think that the improvement are moderate, but one thing that I put here moderate because in the first experiment that we did in observing system experiment is that we were doing some experiment with only 3 nadir altimeter, and so which is quite different than with 8 or 7 nadir altimeters that are constraining the map. So actually, depending on the density of the nadir constellation, the contribution of the Karin may be quite different. So here, the experiment that we perform is kind of a realistic one. So with all the nadir altimeter constellation that are already quite well constraining the scale of the MIOST mapping system. So adding Karin can be seen as moderate in this 7 or 8 nadir altimeter constellation. But yeah, if we had a kind of a reduced altimetry nadir altimeter constellation, the impact of wide swath altimetry could potentially be significantly larger. So this has been published in one paper in 2 years ago about the first assessment of Karin. I think it was with a V1 dataset. I'll put the paper at the end. So overall, there is a lot of challenge still to deal with this new type of observation. So in coastal region, polar region, so there is still some work to do on the mapping system, on the processing of the Karin system to better process the data in those regions. Another point that I quickly mentioned is that MIOST is not able to represent the fine scale structure that are seen by Karin. So the really small ADs are not present by using the MIOST system. So we need to find a solution to preserve or propagate the small-scale structure in the gridded product. So this aspect will potentially be discussed next time with the Vardin approach that is explored by Florian. There is still some effort to consolidate MIOST for operational application. So MIOST is used for operational application with nadir altimetry, and I will mention it later. And there is some kind of demonstration product, so on Aviso, but also on the CMEMS catalog. I will come back to that later. And so the latest point is linked to what I mentioned before. So explore different or alternative mapping approach. So it could be the one that has been done by Florian. There is also the 4D Varnet approach. There is a Neurost approach that has been developed by Scott Martin. There is many approaches that are being developed right now, data-driven approach that could perform better for constraining the small-scale structure seen by SWOT in the level 4 product. Another aspect to bring more finer solution is to combine different sources of observation, such as sea surface temperature, salinity. So that's something that is also potential can be potentially done with the Vardin and 4D Varnet approach. And so for the moment, so previously, so the 4D Varnet and Vardin approach were done at regional scale. So with the V01, so there was some product over the North Atlantic region that was made available on the Aviso website. And now, so we are transitioning towards global implementation of the 4D Varnet and Vardin level 4 product using Nadir altimeter data and as well SWOT. And this product should appear on the Aviso website probably before summer. And so a demonstration product, so is what I say, this demonstration product with 4D Varnet and Vardin will appear on Aviso this year. Just to have a quick overview of what could be the performance of the 4D Varnet approach at global scale compared to the MIOST system. So that's a recent assessment and recent production that has been done with the 4D Varnet approach and compared to the MIOST product. So that's level 4 map that are constrained with Nadir altimeter and Carin data. And we use independent dataset to validate these two series of map over the year 2024. And the 4D Varnet approach is quite good in energetic current, such as the Gulf Stream, along the ACC, Kuroshio. So potentially, so the short, so finer scale EDs are present in this 4D Varnet reconstruction compared to the MIOST level 4 product. Still some problem and some room for improvement with the 4D Varnet approach are the equatorial region and region of also internal tide or gravity, surface gravity waves, such as so the in the Indian Ocean and the Western Pacific Ocean. So that's also some challenge that has to be tackled with the 4D Varnet approach in those areas. So as I mentioned, so the new product will appear on Aviso based on the 4D Varnet approach by the end of the year or before summer. If you want to download the product, so I've put here the link to the level 4 product with the SWOT and Nadir altimetry. For the moment, based on the V3 dataset, level 3 V3 dataset of SWOT, you will find so only the global dataset with MIOST and the other dataset with 4D Varnet and Vardin will appear in the coming months. And finally, I just wanted to mention that also on the CMEMS catalog, there is a demo product that is available. It's a level 4 product in near real time on 1/8 degree resolution, and it includes Karin. It's near real time, and it's available with a timeliness of day minus 6 days, I think. So this product is for the moment in demo mode, and as for the avisos that are available on as for the products that are available on the Aviso website, I mean, all feedbacks are welcome, and that's the best way that we could improve the level 4 product. So don't hesitate to look at this product and send us back some email if you see some bad things, good things on these productions. And finally, so that's the reference of the paper that has been published last year or 2 years ago about the integration of the Karin data in the level 4 product with MIOST. And I think that's all for me.
Well, thank you so much. I'm sure that there are a lot of questions. People can raise their hands or put questions in the chat. And maybe while people are thinking of questions, I'll ask about you're reporting this product at 1/8 degree postings. What do you think the
Yes.
effective resolution is?
So the effective resolution would be coarser than the 1/8 degree resolution. So the gain in resolution, as I mentioned, is
Yeah.
between 10 to 20 kilometers. And so when you have, let's say at mid-latitude, 100 kilometer effective resolution, so it's definitely larger than, so it's maybe a 10 grid point, 10 grid spatial point. So yeah, it's the effective resolution is larger than the posting.
Yeah, so it's a nice convenience to have the high resolution, but users have to be aware of what they're looking at.
Mm.
Yeah. I see several hands up. Greg Jacobs first, I think.
There's the mute. Okay. Next, but it's really nice stuff. Thank you very much.
Thank you.
I was trying to understand your interpolation method. So if I understand correctly, you're using an optimal interpolation with a Gaussian function. Is that correct?
Yeah, I mean the what is done within this method is that there is the covariance of each physical signal that we want to map are represented in the wavelet space. So basically, what has been implemented historically is that the covariance of the mesoscale signal is pretty similar to what has been historically implemented within the DUAX product. And so it's kind of Gaussian approach to estimate the mesoscale structure.
Okay. That was my other question. Early in the slides, you mentioned that the scale can change in space and time, but it sounds like you're using the scales that have been used historically for the interpolation. Is that correct?
Yeah, it's quite close. It's not rigorously what has been implemented in the optimal interpolation that was in the previous DUAX system, but is close to what was implemented. So there was some refinement in some region, but overall, the structure of the scale are really similar. Yes.
So those scales, I don't know, but I could imagine in the past they were adjusted so that the interpolation would be based on what the data resolved, and
Exactly.
the small improvement due to SWOT may be because those scales are already resolved by the nadir altimeters. What are your thoughts?
I mean, potentially we could revisit this scale for the SWOT area, let's say. But one big problem with the SWOT is, or one SWOT, let's say, is a revisit time that you will have at mid-latitude. And that's why some years ago, or maybe it was 10 years ago, there was this dynamical mapping approach that was introduced by Clement, and that is now implemented with the Vardin approach, is that even though if we could refine spatially the scale that we want to constrain in the map during the SWOT area, the difficulty with the MIOST mapping approach will be to how to constrain dynamically in time those scale, meaning that we could definitely decrease the spatial scale and have maps that are that have really fine scale at one time, but we will lose the coherency in time because we don't manage to propagate the information with this mapping approach. I don't know if I answered the question or.
Well, that makes good sense. That's very good. Thank you very much.
But I mean, your question is really pertinent in a sense that at high latitude, also the scale are quite small already in the system for the moment. We could even refine more the scale in using when we use SWOT in those areas. So potentially we could improve the mapping at high latitude where you have revisit times that are really short time scale, and you have a kind of dense observation thanks to the SWOT.
Yes, that makes sense. Fantastic. Thanks.
Next up is Luciana.
Yes, thanks. So it's very interesting. In fact, we have this we have the mapping system that we have to decide which one we have, and we have the data. So if we have a lot of data, but then we smooth at the end, also the data are not really used as we want. So the question is, so if we have seen when we look at DUAX and we compare with SWOT along track, so the grids or profile, we see that there is much less variability. So it is now, I understand that with the new MIOST, it doesn't change much. So have you tried to apply to SWOT alone this methodology to see how much you lose in variability along tracks, for example?
You mean doing a mapping only with one SWOT?
Yeah. So if you change about the data and the methodology, you don't know. But if you have the same data and then you change the methodology, perhaps you understand how that is mooted anyway, as it should.
Yeah, but with one SWOT, so the problem will be, I mean, as I mentioned before, at mid-latitude, the problem will still persist.
The time, yeah. No, just so have an idea if you get a lot of smoothing or not. So this is the question: are the maps much so smoothed like the DUAX, or they are a little bit more less smoothed?
So you do, I will say, compared to what you can see from the level 3 SWOT product, it is smooth. So in that sense, but the fact of using SWOT data in the level 4 product still qualitatively help to better constrain the map and better define the structure of the topography. For example, in the qualitative slide that I've put in the presentation, one AD that or one structure that was represented as only a unique AD with nadir altimetry can be better shape in using the SWOT observation. So from my point of view, using SWOT with MIOST, of course, you will get some smoothing, but you also get some better constraint or better shape of the structure in the map.
Okay, you get the minimum at the right place, probably. Yeah. Thank you.
Next is Dan Witt.
Hi, nice talk. I just wanted to, this may be a dumb question, I'm not really sure, but it's something I've been wondering about just for my own analysis. So if you were to take the map, for example, and extract, like you've done in this picture, a swath, kind of analogous to the SWOT observations, and you were to create like a power spectrum of the as a function of wave number, and look at that as a function of time. I guess I'm curious if there's a kind of increase in resolution near the time of the SWOT pass, or if that's completely gone. Like if you looked at a time series, right, you have these very sparse. Do you see any artifacts of the spectral in the spectral space like that, where you kind of get like an increase in resolution? I guess it's kind of a similar question, like because if you don't see that, then like you're completely throwing away the resolution. But if you do see it, you see what I'm getting at? Have you looked at that kind of an analysis?
No, I haven't looked at that. So your question is mainly on the temporal aspect, right? So if you do frequency wave number spectral analysis, no?
I guess I was just thinking it just sort of in wave number time space, but yes, you could look at it in frequency wave number. But I was kind of just wondering, like, something I've done is to like pull, from mapped products swaths out and then do comparisons at a given point in time. And the Calval orbit's a very obvious one because you have like numerous passes rapidly in time. But I guess I was curious if you saw what you would see or what you would expect you'd see in those wave number spectra.
I haven't looked specifically at it, this temporal aspect. No.
Okay.
But maybe with in situ data validation, I mean, if we have, for example, some mooring or, I don't know, that are recording some kind of topography signal, I mean, that could be interesting to validate the added value of the SWOT in the level 4 product compared to a classical nadir altimeter level 4 product.
Okay, thanks. Ryan?
Yes. So this is kind of similar to the question about what's the autocorrelation assumption on the mesoscale. The other side of this is what noise model did you use? It seems in the SWOT community, we might, right, there are a lot of opinions about what SWOT noise look like.
Yeah, so in the mapping, so there is, so in the definition of noise that we use in this mapping, you have the contribution of the noise that you potentially have on the instrument, and as well, what we call noise is also the scale that we know that we will not resolve within the mapping system. Okay, so basically, for example, the incoherent part of the internal tide, I could consider it as potentially a noise or error level on the instrument that I want to assimilate. So here specifically on this, so in the experiment that I perform, I quantify the kind of a proxy of error that I was performing with classical, let's say, a level 4 product and SWOT track, where you still may get some so unbalanced motion. And so there is a contribution of this not resolved signal that contribute to the noise level that we affect to the system, to the SWOT. So it's not entirely the noise of SWOT that is considered, for example, in the denoising community or etc.
Thanks.
Any other questions?
Yeah, I have a question. Thank you very much for the presentation. I was wondering when would the LWE, so long wavelength error, be released on Aviso? Do you have an idea?
So it is not planned for the moment. So I have to convince the French Space Agency. So it's not, but yeah, it's not. There is no plan for the moment.
Okay, and if you can just comment on it, I did an experiment where I was assimilating SWOT Karen data into QG and shallow water model framework. So basically similar as what Florian is going to present next week. And I did two experiments. First one without the LWE correction, and second one with the LWE correction. And you could clearly see a significant improvement when you were correcting from LWE, and when you were not, there was cases where the adding SWOT carrying data was not improving, and we could not understand why. And so we think that, yeah, it was very important to correct from this LWE signal.
Okay, cool.
Just to
yeah, that would
comment
be
on
cool
it.
I remember that we talked about it some months ago, but probably what you are talking is some more recent results. Yeah, I mean, if you have some slide about it, that could be nice, and I could for sharing as well with CNES, or for potentially including this long wavelength error correction in the product, or I don't know.
Yeah, I could send it to you. This comparison of the impact of carrying data on the mapping product with and without the LWE correction, and you clearly see differences. So yeah, I will send it to you.
That sounds like it would be broadly interesting to everybody. So maybe we'll pick on you to give a talk.
Yeah.
Any other questions? Well, we're coming to the end, and I want to make a couple announcements so people can reach out to Maxime, and probably if you're like me, you have more questions sitting in your and so Maxime will watch out for email from all of us, I think. I wanted to let people know that you may remember we solicited information for a SWOT review paper that's being put together with contributions from each of the working groups. We are running late, of course, but we are working on writing up the data inversion and assimilation portion of that. And we've tried to include elements of all of the mapping and assimilation studies we're aware of. If there's something that you have coming out that has not been on anybody's radar, please email me or any of the other people who are convening the working group so that we can make sure we get it incorporated into what we're writing. We do want to cover literature that's published or submitted or likely to come out, but we want to get everything that we should. And I suspect the same is true for the high-res modeling working group. I don't know if
Yes, we're working on the draft right now. Dan wrote it, and I'm supposed to write the next draft. And then Aragon will look at it.
And so I assume you're in the same situation, that if there's something that should be included that you haven't seen, you need to hear about it.
Yeah, you can email Aragon and Dan and me.
Okay. Anything else that people want to comment on or share?
It was nice to have a joint meeting.
Yeah. Yeah, we should do it again.
Yep.
Okay, well, thanks everyone. And I will, if you know people who missed it, I will get the recording posted to YouTube.
Thank you.